Hi everyone, this is John Kim again, National Scholastic Academy. We're located in the city of Ventura. We work with only high school students. Anyways, here it is, Honors Algebra 2 by Brown. We're doing Chapter 4, Section 2. We're going to do problems 1, 2, 3, 9A, 9B, 14, 17, 20, and 23. And there's no lectures for this. We're going to go dive right into the questions. So here's the first question. Question number 1 says, oh, by the way, here it is right here. The book that we're going to be using is this one right over here, Advanced Mathematics by, what's his name? Richard G. Brown. There it is, Richard G. Brown. I'm not sure if it's a professor or not, but we're just going to call him Brown for sure. So what does the function, what do we do? It says copy the graph of this. There it is. There's your f function right there. On the right, on a single set of axes, draw the graph y equals f of x plus 2. I'm going to do this in red. Y equals f of x, the new function, plus 2. So whatever the old function says, we add 2 to it with the new y value. From 0, 0, it becomes 2, 0. At 1, it was 1. At 2, 1, 2, it goes here. At x equals 3, my y value is 1. It goes up 2 more units here. And at 0, it's going to go up 2 units. So it's going to look something like this. Okay? And of course, you can do the next one on your own. So this 2 tells you, let's get this 2 right there. This plus 2 on the outside tells you it's a vertical shift of 2 units up. If it's minus 3, then it's going to look 3 units down. Number 2, same thing. First, before we do that though, we're going to graph y equals x. Where's my light pen? How do we graph y equals x? You've seen it before. Here it is. And we talked about it a little bit earlier. If we take the absolute value of it, what happens? The y value, the negative portion, bounces back up through the x-axis. So this is what it looks like. Okay. So it looks like a V, absolute value. Okay. So what happens when we graph a new function? Y equals absolute value of x plus 5. That's the same as y as f of x plus 5. So it's going to go up 5 units, and it's going to look like this. And if it's minus 4, then it's going to go down 4 units, or vertical shift of 4 units down. Number 3 is a little bit more difficult. I'm going to put an asterisk right over here. What color shall I use? Let's use, I haven't used blue in a long time. Okay, there's my purple one. Blue. Oh. Make it look just like the book. Okay. So there's your g function, and this is a little bit difficult, so you're gonna have to spend a little bit of time. Let's look at what this says. Part A says find f of 1 minus g of 1. Find f of 1 minus g of 1. At the x value, we talked about this a little bit earlier, okay? F of 2 equals 3 means when x equals 2, there's my x value, the 2 is replaced with x, my y value is 3. So when x value is 1, in your f function right here, that's the blue, sorry, not the blue, the pink, at x equals 1, my y value is 2. That's 1, that's 2. So that's going to turn out to be 2 minus, what's g of 1? At the x value of 1, my y value, the g right there, is going to be 1. 2 minus 1 is obviously 1. That was easy. It says, for what value is f of x minus g of x positive, negative, or 0? this is the part that gets a little bit more difficult. So I'm going to slow down just a little bit more on this one. This is my thick line at 0, 1, 2, 3, 4, 5, 6, and -1. So you have to literally, when x is -1, what's my f? That's my blue, minus my g. That's 0 minus 1, which is -1. Make sure you get these down, okay? When x is 0, f is 1 minus my g value is 1, it's 0. When x is 1, my f is 1, right? No, my f is 2, my g is 1. 2 minus 1, 1. At x equals 2, my f is 2, my g is 1. So 2 minus 1, 1 again. At 3, my f is 2, my g is 1, I'm 0. Notice that that's my y value right here. Up and down is my y value, so here's my f. 2 minus 0, it's going to be 2. And then at 4, my f is 1, my g is 1, f minus g is 0. At 5, it's going to be f, which is 0, minus y value of g, which is 4. No, it's going to be 1, 2, 2, so it's going to be -2. And then f is -1 minus 3 is -4. So it's going to look something like this. Make sure you understand how to do this properly. And if you need to, just stop it and rewind it and then see what happens. Again, let's look at some point at 1. My f value is going to be 2. There's my 2 right there. And then my g value is going to be, looking to this graph, it's going to be 1. So 2 minus 1 is 1 right there. Okay, should be good for all of these. And so where's the positive? It's going to be positive. I'm going to use my orange. It's going to be positive here. It's going to be negative. Where is it going to be negative? Negative here and here. And when's it going to be 0? Obviously, it's going to be 0 at here and here. And part 3 says which one is my maximum. Where's my maximum? My maximum for my x value is going to be right there, at 3. So part C says what's the maximum value of f of x minus g of x? It's going to be f of x minus g of x is equal to 3 right there. And you could have done it this way too. At 3, no, it's going to be 2. Sorry, my bad, not 2. Not 3, 2. At 3, my f is 2. It goes up to 2 units. And then, let's use this pen. F is 2, it goes up 2 units here. So this minus g value is 0. So 2 minus 0 is 2. Okay. Whoops. Let me get this down. Should be 2. Okay. Number 9. Number 9 says here's your f function, here's your g function. Part A says find f of g of 2. Always start with the inside. One more time. Always start with the inside. So we start with the inside. What's g of 2? If I put g of 2 here, wherever there's an x, I replace it with 2. So it's going to be 2 plus 1, which is 3. So that's replaced g of 2. When x is 2, my y value is 3, so that's replaced with 3. So that's the same thing as f of 3. Looking at my f function, which is located right here, when I input 3, it's going to be 3 squared plus 3. 9 plus 3 is 12. And there it is. Part B says, what's f of g of x? That's the same thing as f circle g of x. So these are totally two equivalent statements. When it says it this way, you can always transfer it this way. The way we start is we start with the inside again. With g of x, we replace g of x with x plus 1. Now, this is the part that gets a little bit more difficult, guys. We're looking at this f function, which is located right there, right? Wherever there's an x, we replace it with x plus 1. So see that x right there? We replace it with x plus 1. It tells it to square it right there. Plus, there's an x, we replace it with x plus 1. We substitute this value, whatever's inside, with x. Make sure you get that down. Distribute that out. Becomes x squared plus 2x plus 1 plus x plus 1. Becomes x squared plus 3x plus 2. You can factor that if you want, but you don't really need to factor it. Let's factor that, so it'll be x plus 2 and x plus 1 in factor form. Okay. Next one. For this problem located right here, there's actually two methods to do this on your calculator. And the first way you're going to do it is you're going to use y equals button right there. Input y1 equals x cubed. y2 is equal to x plus 1. And then go to calculate. And then find the intersection. And then find the intersection. And I'm going to show you how that's done on this calculator right over here. I'm going to get the angle right. I'm going to increase my thing a little bit. Okay, that's the closest I can do. Press the y equals button. I'm going to put x cubed. And then the second equation, I'm going to put x plus 1. I'm going to reset my window from negative 3 to 3, negative positive 3 to 3. I like to set the default as negative 10 to 10. And then when I looked at it closer, it gives me a little bit better graph. So here's what the graph looks like. And there it is right there. And I go to second, calculate. And then I press number, what is that? Number 5. 5 is intersect. And I use the arrow key to get to the left of the intersection. Press enter. And then to the right of the intersection. Press enter. And then it sets it now and then calculates it. And the calculation should be 1.325 approximately. X is approximately 1.325. That's where this is two methods. This is method 1, guys. Okay. So let's do this again. Whoops, I know what happened here. I forgot to move this back. Oh, let's move this back a little. Okay, that's too much. So here it is. X is approximately 1.325. So if I put this in here, 1.325, and I cube it, 1.325, and I go to, there's a caret key, and then 3, I should end up with very similar. If I plug into the right side, 1.325 plus 1, I should get 2.325. So looking at it right here like this, 1.325 cubing it, and 2.325. Okay. So I should get the same exact answer. That's method number 1. Make sure you can do method number 2 as well. X cubed equals x plus 1. We're going to move everything, set it equal to 0. So x cubed minus x minus 1 equals 0. And that's your y1. Got it? Again, We're going to set this equal to 0 by moving x and subtracting x to both sides, subtracting 1 to both sides, and so you end up with x cubed minus x minus 1 has to equal 0. And so let's do this again on our. Okay, that's the closest I can get. Y equals, let's clear that line. Let's clear this. Y2 equals x caret 3 minus x minus 1. And then we're going to graph that sucker. There it is. That's what it looks like. Kind of like that. And this time when we do calculate, there's a calculate button, second calculate, you're going to find the 0. Press number 2. And then on the right bound, it's going to be between 1 and 2, right? So press 1, enter, and then press 2 on your left bound, on your right bound. I'm sorry, first is your left bound, which is 1, and the right bound, which is 2. No, let's do it again. Calculate the, so it's left bound is 1, right bound is 2. Press enter one more time, we get the same answer, 1.325. Okay, so I checked it right there somewhere. It should be like 1.325. So let's pull this back a little bit. Pull this baby back. Too much. So that's our answer. So you could have done it y1 equals y2 equals like this, or you could just set this as y1 and find the zeros. Find the 0. This method is a little bit easier, by the way, guys. Number 17. The function is 2x minus 3. G of x is x plus 3 over 2. Show that f of g of x is equal to g of f of x. In other words, show left-hand side is equal to the right-hand side. If you can show that the left-hand side is equal to the right-hand side, then we prove that that's correct. So how do we do that? Use a nice little marker here. Let's do the left-hand side first. Left-hand side is f of g of x. Again, we start with the inside first, g of x, which is x plus 3 over 2. So it'll be f of x plus 3 over 2. That g of x was replaced by x plus 3 over 2, which is equal to, wherever there's an f function right there, wherever there's an x, we replace x plus 3 over 2. So is that 2? So here's your f function, here's your f function. 2, parentheses, the x is replaced with x plus 3 over 2 minus 3, minus 3. That's how you do that. What do you notice about the left-hand side? As you simplify that, the 2's cancel, times 2 divided by 2. Then x plus 3 minus 3, plus 3 minus 3 cancels, equals x. Let's look at the right-hand side. G of f of x equals what? Again, we always start with the inside. It's going to be g of f of x, which is 2x minus 3. What do we do with that? Here's a g function right here. Wherever there's an x, we replace it with 2x minus 3. So there's an x right there. So that's replaced with 2x minus 3 plus 3. See that right there? 2x minus 3 plus 3 all over 2. Remember, we're substituting 2x minus 3 for wherever there's an x. What do you notice? The plus 3 minus 3 cancels. So this will be 2x over 2. So 2's cancel. You end up with x again. Wow, look at that. Whoops. Pull this back a little bit. You end up with x. Okay. 17. About 19 minutes is elapsed so far, so we'll try to make this as done as fast as possible. Part B says show f of h of x does not equal h of f of x, so we're going to use the left-hand rule again. Show that the left-hand side does not equal the right-hand side. Left-hand side is f of h of x. We start with the inside, h of x. What was h of x? Where is it? It's 3x plus 2. And f of that, the function says is equal to 2 times x minus 3. So you go 2 times, replace x with 3x plus 2 minus 3. 3 times 2 times 3x plus 2 minus 3. Distribute that out, get 6x plus 4 minus 3 is 6x plus 1. Let's look at the right hand side. Which is h of f of x. F of x is 2x minus 3. So replace 2x minus 3, that's your f function, with the inside, h of 2x minus 3. Where's the h function? On 17 is 3x plus 2. X minus 3, and then you're so it's going to be 3x plus 2. So you're going to replace 3 times 2x minus 3. So there's the h function. You're going to replace x with 2x minus 3 plus 2. Distribute that out. You get 6x minus 9 plus 2. 6x minus 7. You notice that the left hand side does not equal to the right hand side, and therefore they're not equal. Okay. Number 20. I'm going to do this really fast. What's f of 4? And here's the f function right over here. So it becomes h of g of f of 4. Square root of 4 is 2. Then we do the next one. G of 2. The h stays. G of 2 is plug in 2. 6 times 2 is 12, minus 3 is 9. And h of 9, 9 over 3 is 3. So it is right there. Okay. And let's try to see the composite function. F of x again. Where is it? Square root of x. So it's going to be h of g of square root of x. There it is right there. G of x says to wherever, here's the g function, so we work on this one next. It's going to be h of g of x, wherever there's an x right there, we replace with square root of x. So it's going to be 6 square root of x minus 3, and that becomes the h function. Wherever there's an x, we replace it with 6 square root of x minus 3. All over 3. And there's your composite function. What we could have done was we could have put 9 over in here. Square root of 9 is 3, correct? There's a 9. Square root of 9 is 3. Times 6 is 9 times 6. No, the square root of 9 is 3. 3 times 6 is 18. 18 minus 3, 15. 15 divided by 5. Wait a second. I'm getting, oh no, sorry, it's 2. No, 4. Oh, it's 4 right there. Square root of 4, there's a number we're looking at, square root of 4, which is 2. 6 times 2 is 12. 12 minus 3, 9. 9 divided by 3 is 3. So we get the same answer. If you use the composite function, or if you work at it one at a time. It will be on your test too as well. So work on this. Last question. So here's how it works. This is a little bit tricky. It's not too bad. I went to one of my students today. So, f of x equals x cubed. What does that mean? She goes, f of x equals x cubed. I didn't say repeat after me. I said, what does it mean? Whatever the number x is, you cube it. That's what it actually means. So let's look at the g of x function. It's equal to square root of x. What it means is whatever the value of x is, you take the square root. Obviously, h of x means whatever the value of x is, you subtract 4, and j of x is whatever the value of x, and the function says to multiply by 2. Okay? So I want to figure out what k of x as a composite of these functions look like. first thing we always do is we start with the inside first. X minus 4. Whatever the value of x is, you subtract 4. Wow, that's the h of x function, isn't it? So I'm going to use a yellow mark for there. That's going to be h of x. Okay. And then, after you go take a number, subtract 4, then you're going to have to cube it. What does the cubing function say? It's the f function. So you're going to multiply by half. And then finally, after you cube it, you're going to multiply by 2, right? So let's use, I don't know, orange. You multiply by 2, that says take the j function. That's how you do these composite functions. So that becomes j of f of h of x. You should be able to do all of 23, 24, 25, and 26 all on your own. Good luck on your homework. Thanks, guys, and take care.